Hello. Today we are going to be talking a little bit about calculus, and specifically we are going to dive a little bit into derivatives. We're going to dive a little bit into, and I'm already misspelling it, derivatives. We're going to be diving a little bit into derivatives. So first, it's important to make the distinction, what actually is a derivative? Now, sometimes I think the definition of derivative and tangent line get mixed up. The derivative and the tangent line are not the same thing. The derivative is the measure of the slope of a function at a certain point, which obviously this is used good with things like parabolas, they increase exponentially over time. They increase exponentially. Now, since the derivative is the measure of the slope at a certain point of a function, we use the tangent line to find the derivative. Now, the tangent line is an equation because, it's a line on a graph. That when you plug in an x value in that equation, you will find the derivative, which again is the slope of a function at a certain point. So they're not the same thing, but you use the tangent line to find the derivative. So what I'm going to be using for this lecture here is the calculus lesson 2.1 homework. I don't remember what day we received it. It might have been on Monday of last week, because I'm recording this on Sunday, the 28th of September. But I'm going to be using this as reference. So let's talk about it. So one of the first major problems that we have here is let f of x equal 4x squared minus 5. And then what we're tasked to do is find f of x. Find f prime of x using the definition of a derivative. Now, f prime of x is the tangent line. That is the tangent line equation. Actually, not really. F prime of x is a function that we use to find the derivative, while the tangent line is a line that touches one point on a function, and it has the same slope, both the tangent line and the function at that point. So they're not technically the same, but we do use f prime of x to find the derivative. Now it says find f of x using the definition of a derivative. The definition of a derivative is this. So what we have here, actually, well, let me write it big. F prime of x equals the limit as h approaches 0, and we have f of x plus h minus f of x over h. Now, you may, with some professors or some people, you may find that they write h as delta x. It is the same thing, because really what we're looking for is the change in x. For the purposes of simplicity, we're going to be using h, just because it looks cleaner. Now, f of x plus h, what does that mean? That means for every x, we're adding h to it. So basically what this means is that for every time you see x, like look at this function, for every time you see x, you're going to actually put x plus h. I'm actually going to move this like this, and I'm going to put it over here for safe keeping. Now we have to actually solve this problem. So what we're going to do is we're going to do 4 times x plus h squared minus 5. And this is its own thing because this is f of x plus h right here. So I'm going to put this in big parentheses, and then we're just doing minus f of x, which of course is this equation, or this expression rather, I should say. So 4x squared minus 5. Now at this point, all of this is just a lot of algebra. So I'm going to simplify this for you and we'll cut back. Also remember to distribute this negative over here because this is inside a parenthesis, so don't forget that. Okay, now this is what we have after multiplying all of this out. And you'll notice that we have some things here that cross out. We have negative 5 plus 5, so these cross out. We have a 4x squared minus 4x squared, so these cross out. And then we are left with this. We are left with 4h squared plus 8xh over h. Now that we're here, we can factor this numerator by taking 4h out. So that leaves us with 4h times h plus 2x. And then we have this over h. The h's cross out, which leaves us with 4h plus 8x. So now that we're here, we have done everything that we needed to in terms of this part, but remember about the limit here. We're looking for the limit as h approaches 0. That means that for every h value, we replace it with 0. So after all of this, we're going to move over here now. After all of this, we have 4 times 0 plus 8x. Now this is obviously 0, which leaves us with just 8x. So this leaves us with an answer of f prime of x equals 8x. By plugging in any x value here, we can find the measure of the slope, which is the derivative. So for the function 4x squared minus 5, if I plug in, say, the point 2 for this equation, when x equals 2, that will give me the measure of the slope of this function at x equals 2, which, whatever number that is, actually I can check on my calculator right here. 8 times 2 is 16. I don't know why I have to check on my calculator what 8 times 2 is, but I digress. What this means is that when x equals 2, the slope of the function is 16. Now moving on to the next problem here, it asks us to find the equation of the tangent line to the graph of f of x equals x squared plus 4x plus 3 at the point -3, 0. It specifically says find the equation of the tangent line at a specific point, which makes sense because a tangent line only touches a function at one point. Really what we're looking for is the line that would be made when the slope is at a specific point, which let me explain this with a drawing, right? If I remember from my paper, because it said sketch it on the paper, I'm not going to sketch it here because that's not important. But for the purposes of this demonstration, I remember the graph looked something like this. So this is the function, and this, actually, let me get a different color here. This is the tangent line. It was something like this. Now, this is the tangent line, right? But this black part is the function, and we're looking at for when x is -3, which is about right here. Now, the slope of the actual function is going down this way. So we're looking for the actual equation of the line if it was straight, if that makes sense. Because a slope is a fixed thing. A slope is a very fixed thing. So what we're looking at is at the point -3. Imagine that our line here was a completely straight line. And it's the same as this black part of the slope. We're looking for the equation of this blue line right here, if that makes any sense. And to do that, we first need to solve for the tangent line like we did in the last problem. Now, if you'd like to do the math, that's great. I won't do it here, but eventually you get to something that looks like this. You get h plus 2x plus 4. And remember that we're looking for the limit as h approaches 0. So you plug in 0 for h, and you get f prime of x equals 2x plus 4. Now we are looking for the line at the point -3. So what we're going to use here for this is actually the equation y equals mx plus b. So first, we need to find the slope at -3, which is the derivative. So all we need to do is plug in -3 here. So 2 times -3 is -6, plus 4 is -2. So we know the slope is -2. That is our m, -2. We also know that our x is -3 because that is the x value. So I'm just going to put -3. Now to find our y value, what we're actually going to do is we're going to plug in -3 to this function as f of x is equal to y. When we plug it into this function, we actually find that we get an answer of 0, which I suppose makes sense since, it's literally right here. I would assume these two are connected, but regardless, you plug it into this equation right here and you get 0. So our y value is going to be 0. Since we're finding the equation of the line, we need a y-intercept. So what we're going to be doing here is actually solving for b. This is what we want. So after all of this, we're going to plug in everything into our equation. So 0 So now we've found our b value. So what does this mean? We're trying to find the equation of the line, and now we have everything we need. So our final answer is going to be y equals -2x, it's a slope, minus 6. This is our final answer. This is what we are looking for. And remember, if we make a graph, if we make our graph again, and this is the slope, just imagine that's -3, you can see it is going down. It is going down, and the y-intercept is somewhere around -6. So it does make sense. Now we are going to move on to our next problem. Our next problem says the line, let me type this out, might be better, in black. It says the line that is tangent to P of x at -2, 6 passes through 5, -1. What is P prime of -2? Now, we know that a tangent line only touches a function at one point. However, this says that the tangent line passes through both this point and this point. How can it pass through 2 points? Well, this only can mean one thing. This means that the tangent line and the actual function are exactly the same. So the tangent line and the function are the same. So the function is a line, and it's the same line. So we don't actually have to plug in, we don't have to use the definition of a derivative, we don't have to do any of that. All we need to do is find the slope of this line, because that automatically will equal the slope at any point, including -2. So, what is the slope? Well, rise over run. So we can see that it goes down 7, and it goes up 7. So -7 divided by 7, well, that equals -1. So at p prime of -2, the slope is -1. And that is our final answer. Now we're going to be looking at the final example that we're going to be going over today. I will post some bonus things at a later time, but as for right now, this is the final thing we're going to be looking at. Now this next problem says use the limit definition of a slope at a point, the alternate form of the derivative, defined to find f prime of 4 if f of x equals the square root of x. An alternate form of the derivative, I'm sure you heard. What is this alternate form of the derivative? There is a form of a derivative, or should I say, using the definition of a derivative, to find the slope at any point automatically without having to find the actual equation of the line first, if that makes sense. So I'm going to write it down. We have f prime of c, because we're looking at for the slope of a point. And then we have equals the limit as x approaches c. We have f of x minus f of c over x minus c. So this is used to find the slope at any point without having to find the actual equation of the line first, as we did in our first example, or one of our first examples, whichever one it was. Now we're trying to find f of 4 here, f prime of 4. So what we're going to do is notice how these two are the same. These are in the same location. We're going to use 4 for c. Now remember, we are not using 4 for x. We are using 4 for c. So as we did earlier, I'm going to move this up here. I'm going to move this up here for safekeeping. Now, we're looking for f of x. So we have square root of x, because we're looking for this. And then we have minus f of c. So all that we're doing is we're plugging in c to this. That's all that we're doing. Because remember, we're just plugging in c. It's just we're looking for a certain point, or a certain x value, I should say, to this function. So we have 4. The square root of 4 is 2. So we have rad x minus 2 over x minus 4. Remember, that's our c value. Now what we're going to have to do here is use the conjugate. So we're going to multiply this by rad x plus 2. And the same for the denominator. Rad x plus 2. This becomes x minus 4 over x minus 4 times the square root of x plus 2. Now, of course, these cancel out. So we are left with 1 over rad x plus 2. 1 over rad x plus 2. Now, I know that I said earlier that we're going to use 4 specifically for c. But once we get here, we do have to plug in 4 for this x, because keep in mind, it is still an x value. We just used it for c up here. Because f of x is this. F of x is the square root of x. But that specific x value is 4. So once we get here, we are tasked, and we must plug in 4. So we have 4 for x, rad 4 plus 2. This simplifies to 1 over 2 plus 2, which is 1 over 4. So we're looking for f prime of 4. F prime of 4 equals 1/4, which again means that the slope of the function at the x value of 4 is equal to 1/4. This is our final answer. So that's going to be the end of this video. In this early stuff, I think that a lot of it is just algebra. A lot of it is just, trying to simplify these things, whether it be using the conjugate or having to simplify stuff like in our first problem. So it really is just stuff like that. So I think, just practice. And I hope this video brought you more understanding. Again, if you have any questions, please leave them in the comments. I'll try to help you, especially if you go to Bonner Springs High School. I'll try to help you guys as best as I can if you need my help. But hope you guys are doing well out there. See you guys next time, and peace.